Hello and welcome. My name is Brett Schuhart, and this is a continuation of the RPN calculator demonstration. When last we left, I had just added add, subtract, and factorial operations to the calculator, and I observed that there's some duplication. Now I'm going to get rid of that duplication, but before we get rid of the duplication, there's other things I want to address. This calculator, as written, has an open-ended API. Every time I add a new operator, I'm going to probably add a new method. The problem with that is, as you add new code to an existing class, chances are good that you're going to break something. So I want to try to minimize that chance, and I also would like to be able to add new operators without changing this class. You may be familiar with the open-close principle. That would be an example of that. To do that, I'm going to have to lock down the API. So the initial design was to have a method per operator, or maybe there wasn't a design, but that's just a decision I made. I don't like that decision, so now I'm going to change it. So I'm going to add in a new method on the calculator that allows the execution of operators by name rather than calling individual methods. That'll narrow down the API. That won't immediately fix the problem, but what it will do is it'll get the problem under control and behind the class rather than to all the consumers of the class. So to do that, let's go ahead and write a new method, execute, using some basic TDD. Alright, so I'm going to create a new test class. And I'm going to, this is going to be testing the existence of operators. So alright, so I'm going to have just this, the whole purpose of this class is to know about operators that are registered for the RPN calculator. Alright, so let's see. I'll create this method. Should be able to add. Now I've already got a test like this. I'm going to go ahead and I guess I'm going to copy it for now, and then I'm going to maybe see if I can figure out a better way to write it. So we have something like that in, well, here we go. I've got a calculator with some values. Okay, so I think I'm going to borrow these for now. Calculator, great. So now I've got a calculator with two things already pushed. So if I just do calculator.add, execute. Okay, that method doesn't exist, so I'm going to go ahead and create that method. Let's see. Alright, and then I'm going to verify that add actually did what I expected. So 42 plus 2 should be 44, so I guess assert equals. Okay. Now this test is going to fail because, of course, that's not what the value is. That I don't have execute doing anything. So let's go ahead and make execute do some work. Alright. I guess I could just call add for now and get that test to pass. Okay, great. Test passes. Now, let's keep going with this. I guess same thing except now subtract. And I guess this is 2 minus 42, so that's minus 40, I think. It fails. Expected minus 40, but it was 44, so now I need to fix that. So I guess if okay. Huh. I pushed 42 first, didn't I? Yeah, I sure did. That's just me making a mistake. Alright. Great. Now I guess factorial. Alright, let's see. I guess I'll do this. Now what's currently on the top of the stack is 2. The factorial of 2 is 2, so in fact, as written, I believe this is going to work. So that's a problem. I'll just do a drop for now. Well, I don't want to calculate the 42. I guess what I'm going to do is I'm going to go back and change value 2 to be something a little bit larger. Make sure those work. Sure enough, it doesn't. Let's see. Oh yeah, 42 minus 4 would be 38, sure. Alright. Now, the factorial of 4 is 24. That'll fail. Okay, so now I need to fix execute to work for the last example. Okay, great. Now, before I go on, I'm going to add another test. This opens up the possibility of what happens if you provide a an operator that doesn't exist. Let's go ahead and define what that will happen in that case. Let's see. That should be okay. Now that should throw an exception, so I guess expected. So I'll throw that as an exception. Oops. Create that class as a subclass of runtime exception. Okay, there's a nice example. I'll run that. It fails. I expected an exception, but it did not throw no such operator, so now I need to make sure that execute throws. Okay, so else if it equals this, okay. Alright, there we go. So now it only does add, subtract, factorial, or it throws an exception. So that seems a little bit better. And you think, well, what has this done? Okay, so I've now put in the support for this new API. What I'm going to do is go back and update my existing tests to use the new form of the code. So notice, I try to not change test and production code at the same time. So I wrote some tests, it changed the behavior of the class, and now I'm going to go back and update all the classes. Now there's that use, add, subtract, multiply, and divide. I'm going to go ahead and use a technique Michael Feathers refers to as relying on the compiler. I'm just going to take the add method in the RPN calculator and see how invasive it is. So let's see. Let's find add. I'm just going to make it private for a second. And how many? There's only one error. Okay, that's pretty good. So, great. Okay, let's see if that still works. Alright, looks good. Break anything else? I'm going to go run ahead. We're going to run all the tests. Everything runs great. So I'm going to go ahead and do that with subtract now. Okay, also only one place. That'll be execute as well. Tests are still passing, and then finally factorial. I got that in 2 places. Let's see now, did that work? Okay, great. So now what I've got is I've got a calculator with a single method. As I add new operators, I'm still going to have to change the RPN calculator class, but the API is stable. Now that I've got the API stabilized, the next thing to do would make it so that that functionality is not implemented within the calculator, but is separate to the calculator. And that's going to be the point of the next video.